Hey guys, so I'm going to give you a lecture on terminal speed. So this is 8.3 in the blue first year physics textbook. So I'm just going to start by talking about what do I mean by terminal speed. So you're all happy with what the speed of an object is and what the velocity of an object is. But terminal speed means the maximum possible speed that an object can actually get to. So what we actually are talking about here is we need to introduce a drag force. So that means we need to start talking about air resistance, we call it water resistance or upthrust. You might have used these terms before. We're not going to use these. Now, we're just going to use the word drag. And what you need to know about drag, it opposes motion. So your drag opposes motion. So let's just do a very quick example here. Say we've got something that's an object moving through through some water. So I'm going to really badly draw some kind of measuring cylinder here, and we've got like a cube. If we quickly draw the forces on it, we're going to have weight acting downwards, and we're because the object is moving downwards, we're going to have our drag force, which is acting in the opposite direction. Now, in water, because water is quite a dense fluid. Now, a fluid is either a liquid or a gas. If I use that word, a lot of fluid is either a liquid or a gas. Essentially, objects can flow through fluids. We've got here our weight is equal to our drag. So if we do our forces, our sum of the forces equals ma here. What you'll find is W minus D equals ma. Oh, someone's doing some hoovering, so that will make the rest of the lecture quite interesting. But if W equals D, then this will become 0. And obviously our mass isn't 0, so our acceleration here is 0. Therefore, our velocity is constant. And that's terminal velocity. Now, why is it terminal velocity? Because it cannot get any quicker. So, let me give you another example of... Oh, there's my daughter saying hello. Let me give you another example. And let me do kind of like a time... Go forward in time. Say someone jumps out of an aeroplane, right? Obviously with a parachute, because you wouldn't want to be jumping out of an aeroplane without a parachute. So, let's have like time equals 0. Let's have, I don't know, time equals like 1 second, and then time equals like, I don't know, 50 seconds. I don't know how long it takes to reach terminal velocity, but we'll say it's terminal velocity of 50 seconds. Time equals 0. Person jumps out of a plane. Forces on that person, they haven't got very much velocity at that time. So our forces, we've got weight here, and maybe a very tiny bit of drag, so they might have just started moving downwards. At time equals 1 second, they've just started moving downwards a little bit faster. They haven't gained any mass, and we're going to ignore the change in gravity. So their weight is unchanged. But they've got a little bit higher, so their drag force is getting a bit higher. and at time equals 50 seconds. Oh, what's happened to my man? Time equals 50 seconds. His drag force is equal to his weight. Now, let's just do our sum of our forces equals ma on each of these. Let's see what happens. So, sum of the forces equals ma. So here, we're going downwards, so we have downwards our positive direction all the time. And all this, and our acceleration is obviously downwards because we're jumping out of a plane. So we're going to have W minus D equals ma. So the acceleration that he feels is W minus D over M equals A. And that's going to be true for each of these scenarios. T equals 0, T equals 1, and T equals 50. But what do we notice? The key point here is his velocity is increasing. So as you move from T equals 1 to T equals 50, his velocity is increasing. But as your velocity is increasing, sort of meters per second, you're going to hit more air particles per second, right? So actually your drag is going to increase. So the drag force you feel will increase with velocity. So this is, you ever stuck your head out the window when you're going at 30 miles an hour in a car and then went at 70, or your hand, you feel far more drag force going at 70 than you do at 30. I wouldn't advise sticking your head out of a window, by the way. The hand is probably alright. So your drag force increases with velocity, and this is the major thing that you need to know. Drag force increases with velocity. So if you know that, then you can do quite a lot of these questions. So if we now look at powered vehicles, right, and we look at terminal velocity of cars, right, so we've got cars with the same engine. Let's be very clear about this. Let's have engines as our control variable. We've got two cars, right? Here you go. That's one car. And you got another car here. So car 1 and car 2, right? Same engine, so same thrust. Which one is going to have the higher terminal velocity? The answer is going to be this one, number 2. So this one is going to have the higher Why is that? More aerodynamic. Well, what does being more aerodynamic do with having a higher terminal velocity? Well, let's have a look. So let's now say that these cars are now going to move along the road at a certain velocity. Well, at a certain velocity, because this first car is not very aerodynamic, it's going to have a drag force. But the drag force is going to be higher. So this car might reach terminal velocity. It's going to reach terminal velocity a lot sooner than the second car, because even though it's got the same thrust, it's going to have less drag. And this is the basics of aerodynamics, minimising the drag. Now there are various variables that minimise the drag. You've got the area, you've got a coefficient of friction, coefficient of drag, Reynolds number, various different bits and pieces that we don't need to go into, but they're all Oh, and the density of the fluid that they're going through. Various different things that we don't need to go into in this course. If you're interested, go and look it up. But yeah. So let's just look at what the acceleration of these two cars would be at any one time. Well, we can just do the sum of the forces equals ma. Sum of the forces, let's just say that this way is our positive direction and it's accelerating that way. So therefore, sum of our forces would be thrust minus drag over mass equals the acceleration. So, or the force of the engine minus the force of the drag over the mass is going to be the acceleration at any point. So that's why sports cars can go faster, or have a higher terminal velocity, as well as having a bigger engine, of course. So this has been a very sort of kind of quick introduction to terminal velocity and terminal speed. If you have any questions, please do comment, and I'm going to upload the work solutions to the 8.3 summary questions as well.